Good morning, everyone, and thanks for joining me for this presentation on electric vehicles and how Amendment 1, when it came out last year, has affected things. So a brief summary of what we're going to cover. It'll be a brief introduction on electric vehicles and the reason why we had an ahead of schedule Amendment 1 released. We'll list what changes came in and how does that change the way you need to be installing electric vehicles. And also we'll look at what now, so what to the future. As we all know, we're in a very changing world, and none more so than at this current moment in time. Hopefully life will begin to normalise, and part of that normalisation will be ensuring that life doesn't go back to normal. By that, of course, I refer to getting back to the business of decarbonising our society and our practices, and in reaching the government's legally binding commitment of net zero carbon by 2050. In order to do that, we need to reduce our energy demands and, in turn, our carbon emissions. And the energy we do need to use needs to be sustainable. We know all this, and we've known this for a long time, but we're still where we are. Our current crisis has given everyone, including industry and government, a chance to step back, breathe, and hopefully realise that we've got an incredible opportunity to address the issue of climate change and our economic restart in a collective manner. After all, billions of pounds needs to be spent to get the economy back to where it was before, and billions of pounds needs to be spent to prevent our planet going into thermal runaway, the existential threat. So it's best to incorporate the two, and that is the most economic way to manage these two issues. Importantly, the bulk of this work must start now. So over to electric vehicles. We have gone through the early adopter phase, and we're beginning to move towards greater adoption. 2019 and 2020 saw huge growth in UK EV ownership, and in 2014, the registrations of electric vehicles was only around 500 per month. That figure now exceeds 5,000. Even though the automotive industry was slow to bring electric vehicles to the masses, there's now over 135 different plug-in electric vehicles, and this is a figure that's rapidly growing. We've got 4 key barriers to adoption. These are the charging, the cost, the choice, and the performance. But these are all now being addressed. The greater choice of vehicles has come to market, and pricing is now becoming competitive against traditional vehicles, as well as there being subsidies for new electric vehicles and charge point installations for both domestic and commercial users. There are over 300,000 registered electric cars now. Sorry, these figures are a few months out of date. Over 9,000, I think close to 10,000 registered electric vans, and probably now close to 35,000 electric vehicle charge points installed in the UK. So the growth of vehicle adoption is marrying up in speed with the rate of deployment of electric vehicle charge points. So it is clearly happening. You can see these figures from the Society of Motor Manufacturers, and this shows that year on year, the BEV, so that's battery electric vehicles, the sales have seen a just shy of 50% increase in sales in February this year to February last year, and this is reflected on a year-by-year total as well. So there's a clear direction. People are beginning to adopt the vehicles. Sales of diesels and petrols, I mean, diesels have fallen by 62% and petrol close to 50%. So people are beginning to take the journey, and this is very apparent when you look around the roads. There's a number of charge point incentives out there. There's the workplace charging scheme. There's a grant of 75% of the installation up to £350 per charge point, and that can be used for 40 times if for the commercial workplace charging scheme. Okay, £350 isn't going to cover the cost of an installation, even if it was around £500, but it's still some way to help people to incentivize people to have the charge points installed. And especially if you're a large organization and you're looking to have up to 40 charge points, 40 times 350 is quite a lot of money towards what's being installed. On the domestic side, you have the electric vehicle home charge scheme. Again, same figures, 75% up to 350. There's also the benefit in kind to help people, to help company car drivers adopt electric vehicles. This is currently 0%. From the 1st of April, so a couple of weeks, that will go up to 1% and 2% the year after. But that does offer a good few £1,000s in savings, tax savings, that people would be able to gain through these. There have been a couple of issues with OLEV. This is the elephant in the room. And there were significant payment delays that were happening to installers trying to process these schemes. And they had been refusing submissions for non-existent or for minor errors. Luckily, they have been addressing this. They have listened to industry. ECA did make a number of proposals to them, and we took on feedback from our members. And OLEV, over the past few months, have simplified the process of registration, and also for the amount of information and the type of information that needs to be submitted. There's also been the advent of third-party solutions, such as EV Comply, who have put together a very good software package and an app and a web-based solution for installers to collate the information from their initial surveys through to the installation, linking documentation to make the submission to OLEV a lot easier. We have a number of members using this software, and yeah, they have found it has saved them many hours each month. There's further legislative drivers as well that have helped to see the adoption of electric vehicles coming through. You've got the and also for the drive for the net zero carbon entirely. You've got the adoption of the Energy Performance Building Directive, which is a European directive, but we were still in Europe at the time, so we did need to adopt that. You've got the changes in the Future Home Standard, Building Regs Part L and F, which is in consultation at the moment. I advise everyone to look at this and make comment either to ECA or directly to government on the changes. And some of these standards are, especially through the EPBD, now mandate charge points for new builds and also for existing buildings undergoing existing renovations. You've got the ban on internal combustion vehicles. Internal combustion engine vehicles was originally set at 2040. This is now 2030, so we have 9 years to get a full rollout, which is attainable. It certainly is attainable. And that's only for the sales of internal combustion engine vehicles. They're not being banned from the roads. You can still use them. There's lots of conversations out there that, oh, it's still a mess out there. People, there's so many different types of chargers. Why isn't there a unified standard? To be honest, there is. I mean, if you look at this this chart on the screen, it's showing 7 types of connectors, which can be used for electric vehicles. You can discount 2 of them almost straight away. You have the 3-pin socket and your commando socket. Okay, you do get supplied sometimes with a granny charger for slow charging of your vehicles. They're limited to 10 amps, but these should only really be used on uprated 1363 sockets. The reason is most of our sockets or standard sockets aren't designed for excessive continued use. If you think these mode 1, mode 2 chargers that are being used here, they'll be pulling, I'll take a mode 2 charger, 10 amps constantly. If you're filling up a 50 kilowatt battery car, say a Renault Zoe, it'll probably take about 11 hours. So that's 11 hours constantly pulling around 10 amps. Okay, there is a variation due to the charge cycle and conditioning, but if you took that as an average, 10 hours, 10, 11, 12 hours, pulling 10 amps, that's a big thermal load that's being put onto the sockets and the cabling behind it. So there's more chances of thermal degradation. So they should only really be used occasionally. Anyway, that's a bit of side waffle there. In the main,
Sorry, I couldn't hear what you said.
Apologies about that. In the main, there are two types of vehicle connectors. You've got the Type 1 and the Type 2. And the Type 1 was on older vehicles, mainly South Asian type variants. But Type 2 in the main is being used for all the vehicles going forward. So this is part of the AC connection that can deliver between 3 and 43 kilowatts on single or three phase. And on the DC side, you'll see there's a CHAdeMO, which was used in the Nissan Leafs and the Outlander. But these, in the latest vehicle that's coming through, the next Nissan, that's now been discontinued. And in fact, the current Leaf has Mode 2 as well. CHAdeMO can be used for vehicle to grid, etc., etc. But Type 2, if you look at the screen, the Type 2, which has the green circle around it, is also combined into the CCS, the Combined Charging Standard. I think that's what CCS stands for, something like that. And it's also very similar to the Tesla, which is a Type 2, but with a notch taken out so that only Teslas can use their supercharging stations. So going forward, everything is going to be based on CCS. The bottom two components we'll look at in a sec, but CCS incorporates Type 2. So going forward, everything will be the Type 2 CCS connectors. I've mentioned that already. And that. So yeah, we'll have a quick look at the connectors themselves. So as I mentioned, this top part is the Type 2, and the overall part here is CCS. The bottom two connectors are the DC, so this is for your high-speed motorway charging stations. Some versions of this are delivering up to 350 kilowatts, which is a mighty belt. But in the main, at home and most commercial installations, they'll be just using this top part here. So how does this appear in vehicles? On the left-hand side, you have a pictorial there of the CCS. So this is being plugged in just using the Type 2, which is what you'd standardly have on a domestic or a commercial installation. When you're in public high-speed DC charging, it would be utilizing those bottom two. On other vehicles, like this Nissan Leaf, you've got the Mode 2 there, the Type 2 connector is plugged in, and adjacent to that, you have the CHAdeMO connection for doing your V2G or that version of high-speed DC charging, which is going to be less and less apparent going forward. Right, back to the things you're probably interested in. What do you need to consider when you're installing electric vehicle charge points for people? Well, you need to ensure that there is supply capability. Essentially, it's the end user's responsibility, but you as the installer are most likely to be suited to assist with this. How is it going to be located? So you need to plan the location. Is it viable where the customer's intending? Obviously considering cable runs, clipping, etc., etc. And also the adequacy of the existing supply intake equipment. So you need to make sure that the DNO cutout, the metering and the meter tails are in a good, suitable condition. And if they're not, you need to notify the DNO before you do any install work. If you deem that the maximum demand of the property is going to be less than 13.8 kVA, essentially 60 amps, you can install and then notify the DNO within 1 calendar month. So you can go ahead, install the EV charge point, and then make a DNO application. There's one form that they use, which is for electric vehicle charge points and heat pumps. It's the same form. You can find that on the ENA website, or you can consult the relevant DNO and get it from their website as well. If the maximum demand of the property is greater than that, or, as I mentioned, if there's an issue with the adequacy or the existing service equipment, you must contact the DNO first for approval. Because if the demand is so great and it's going to push over their what they expect to be drawn from the property, they may need to check that the connectivity and the connections to the network are man enough are strong enough to make those connections. So on to Amendment 1. Okay, this is just over a year ago that this came out, and Amendment 1 to the wiring regulations solely relates to Section 722. It allowed for advances in EV charging technologies which hadn't been available before, and it also gives new options for the electrical contractor in how to install electric vehicle charge points. This amendment was free to view and free to save electronically, but if you wanted a printed copy, you had to download. You had to pay £5 to be able to download and print. Each their own, depends how people like to work. There was a minor corrigendum after this, just corrected a couple of things. It was a minor thing on one of the equations hadn't carried over. So what else do you need to consider? Well, you've got the different wiring systems here. You've got TNC, TNS, and TNCS. So it's stated in 722 that the final circuit supplying a charge point shall not include a pen. Fair enough. A number of buildings have TNS connections to them, but unless it can be guaranteed by the DNO that the TNS will never, that it is TNS back to the source and will never be converted to a TNCS PME system, the system must always be treated as TNCS. This doesn't apply to private networks where they will probably own the substation and it will always remain as a TNS as the customer has full control of that. So you can install electric vehicles with no additional protection on a TNS system if it's private. But when it's a TNCS PME type system, there are particular requirements, and this is solely to address the issue of broken pens. There's a minor number of instances out there, cited roughly one a day, of broken pens. So this is where the earthing and the neutral in the connections to the supply between the supply and the building may become broken. So this is a lot of onerous activity to protect against something which is a minor incident, which is deemed as tolerable by the HSE, and so we are where we are with that. Okay, so I've said when it's a TNCS, there needs to be special considerations. If the charge point is going to be installed within a building, perhaps an internal garage or an underground car park, then PME can be used without special earthing measurements, so long as the cabling, the charge cables, don't extend out beyond the realms of the premises to outside, so outside a garage, etc. So that is an acceptable time to use PME. But in the other instances, the original options from 722 do still apply. The changes added in some additional things. So one of the existing measures was to adopt a protective measure which didn't at that time exist. So this was in 722.411.4.1 indent 3. It's a long regulation. This was colloquially known as the unicorn device, and this monitors the voltage between the CPC and earth to ensure that it remains below 70 volts. These devices are now available, but they do require an earth reference electrode. So this is a smaller electrode. This isn't to shunt the entire fault current down, so it's just a monitoring electrode. So that was one option, which still exists. And another was to use for electrical separation. This is a great solution, although they are expensive, they are heavy, and they are cumbersome. And unfortunately, the vehicle may not charge due to issues with the handshake. So that kind of precludes a lot of the options for using that. And you've got, currently you have the option to use a balanced three-phase system if the three-phase system to the building is balanced across the loads. And you also have the option of TT. So TT, okay, that does mitigate against a lot of the problems, but it also brings in its own issues as well, as we'll see in the next slide. So with TT, there are some potential issues. There's the risk of going through HV cables in the ground, which are unbeknownst to the installer. There's also the risk of hitting underground strata, and to reach the resistances needed, you will likely need multiple numbers of earthing electrodes, as you can see here. So all three of those are annoying issues. Okay, number one, if you went through an HV cable, that's more than an annoyance, it's a clear health and safety issue. But the risk of ground strikes, having to remove and move and locate your earth rods in different locations, is an onerous time. So this is they're onerous activities, potentially dangerous due to unmapped underground services, and often electrical installers may be unaware of their insurance limitations. It's quite often that their groundworks are limited to 1 meter's depth. So it's important to check what your insurance covers you for. Luckily, TT isn't now necessary. It's an option, but it isn't necessary. So you have a new option in Amendment 1, and this was through Indent 4 of 722.411.4.1. And this allowed you to provide protection against electric shock in a single phase installation through a single device which disconnects the vehicle electrically from the live conductors of the supply and the protective earth. This needs to operate within 5 seconds. If the supply voltage at the charge point is above 250 volts or below 207 volts. This can only close or reset if the voltage is back within its tolerable area, and equivalent functionality of this may be incorporated into the electric vehicle charge point itself. This is commonly known as the open pen monitoring device. It can be, as was stated there, contained within the electric vehicle charge point. I believe My Energy Zappi devices incorporate this within their chargers, or it could be through standalone devices such as the MATI open pen device. I think Garrow do a similar unit, but it's important for the contractor to check how these things operate and that they do comply with the relevant standards. Probably best to ask for a stick just to ensure that the onus is passed back to the manufacturer on that. So if you use one of these devices or one of these charge points which has it already installed, then no groundworks are required. It's important to point out here there have been a couple of issues with solar PV when using these. As mentioned, if the voltage that is being seen at the incomer to these devices exceeds 253 volts, the charge point or the protective device will turn itself off. Now, sometimes if the building is sited close to a substation, or they have high incoming electricity, and they also have solar PV on the property, in order for the solar PV to export its energy, it raises the voltage slightly above that coming into the building. In certain instances, this may cause that voltage to exceed 253 volts, in which case the EV charge point would turn off, and then the customer wouldn't be very happy. We've seen a couple of instances of this. Is just something to be aware of. It doesn't happen very often, but if you start getting nuisance calls out by customers and they have got solar PV, do check for this, because it could be that there is that issue that they're in an area with a high supply voltage. I mentioned the original Unicorn device. The text has been amended just to say that it's specifically there to protect against a broken pen contactor. So I won't labour on that point. And there is also a future-proof regulation, Indent 5. So this now allows you to offer protection against electric shock provided by the use of an alternative device to those in the other indent that doesn't result in any less degree of safety than those. And this allows industry to develop new devices which will conform, which will provide an element of safety without the need for changing the text in 722 or requiring another amendment. So the reference to diversity has been removed, and the reason for this is more of the onus has been put on load control. And load control, we'll see how that operates in this short video. If you had 120 amp supply in one vehicle, that vehicle would get 120 amps. If there were 3 vehicles, that would reduce that down across the charge points to 40 amps apiece, and 2 vehicles would become 60 amps apiece. So it monitors. This example here is for a multi charge point location where you've got different charge points but a set available supply. So as you saw there, it would vary the amount of current, the amount of power that's being offered to all the vehicles according to what's available and the number of vehicles there. So okay, that's for multiple charge points. But how would that apply on a domestic scenario? Well, it's a similar kind of setup. If you had a 60 amp supply to a property and the house was using 40 amps, that would attribute 20 amps to be available to the car. Now, if an air source heat pump came on, the house was still using 40 amps, 12 amps is going to the air source heat pump, that reduced down to 8 amps for the car. As the load in the property reduces, that will then increase the load available to the car. As you can see in this instance, that has then gone up to 26 amps. So this works by smart monitoring, monitoring the availability. It set the availability that's coming into the property. It will monitor the loads of the building and specific. It could monitor the entire loads or specific loads like the air source heat pump, which is going to be a heavy demand, and also the outgoing to the vehicle. So it cleverly balances everything, and that ensures that you will never go above the demand that's being placed onto the vehicle, placed onto the property. Apologies for that. A couple of other changes. It spoke about RCDs. It's very important that the right sort of RCD is selected when installing electric vehicle charge points. These can be either a Type B RCD, which is built to be able to tolerate DC noise and not become blinded by DC noise, which is more and more apparent in many of our in our properties now due to the increasing amount of DC componentry that's installed and in use. So you can use a Type B RCD or a Type A or Type F RCD in conjunction with an RDC DD. So what the hell is an RDC DD? It's another long acronym, but it does stand for the Residual Direct Current Detecting Device. So this takes the part of this the DC element that's contained within a Type B RCD. So you're not precluded from using a Type A, but you would need to use it in conjunction with the RDC DD. Again, some of these may be contained within the OpenPen protective devices or the EV charge points. Again, it's important that you clarify with the installer what type of protection is being provided. You have the option of V2G coming through. There's a number of V2G trials going on. So V2G is vehicle to grid, and this is a bi-directional connection of the electric vehicle and the grid, with the vehicle being able to store and offload energy to and from the grid as required. It is hoped that by correct implementation, this will help to reduce costly grid infrastructure upgrades being required. And this is also, the concept is also being viewed as a V2H, so vehicle to home scenario. There's been a number of studies underway, including one by OVO and partners involving 1,000 real-life installations. And it's important to note that the UK government is keen to put this country at the forefront of battery technology. And so we are seeing increased investment and trials in this area. So this is being deemed as the golden egg for the grid operators, and it does feature in the National Grid Future Energy Scenario. They've said that by, I can't remember when, I'm guessing by 2050, 38 gigawatts of flexibility from 5.5 million vehicles may be in use. And by 2050, up to 80% of households may be able to charge their vehicles and actively be part of these solutions. So what's the rollout of EVs mean for your businesses, and what does the change in Amendment 1 mean to you guys? Well, installations for electric vehicle charge points can now be a lot simpler. There's no need for TT installations or worrying about the underground services or the differing earthing systems or the ground rods affecting zones of influence. The original options from BS 7671 are still available, including TT, as I mentioned. New technologies may come in without the need for altering regulations, as long as they do satisfy the safety criteria. And it's important that you know how your electric vehicle charging equipment satisfies the regulations. So it's important that you ask your manufacturer or your distributor for declaration of conformities. And EV infrastructure will play a key part of electrical contracting works going forward. Okay, they don't have a massive markup, but the sheer amount of them means it should be an important thing that you add to your portfolio. So where can you get guidance on this? We have published quite a lot of guidance. We've got some specifically on the electric vehicle charging. We've got others on navigating the process of registration with OLEV, which, as you can imagine, can be a bit onerous. And there is also the IET Code of Practice. So that's now in its 4th edition and does cover a range of scenarios. In order for your clients to be able to receive OLEV funding, you would need to have done some EV training, i.e. through NIC, EIC, or through the Learning Lounge EVE program, which is a very good online course. If you can't spare the time out to go and attend a 2-day course, etc., it's worth looking at the online offerings from Learning Lounge. It's an extensive course. You can do the course online and then Sitting Guild 2919 course in a range of locations. In addition to this, you would also need to have had some manufacturer's training. Once you have all that, you can register with OLEV, and then your clients, whether they're commercial or domestic, will be able to receive that £350 grant towards it. And I think, ladies and gentlemen, that is everything. So unless there's any questions, and I can't see any in the chat, thank you for your time. I hope you found that informative, and yeah, enjoy the rest of the webinar this week. Thank you very much.